now what we're going to look at is arc length and area of sectors. So we'll start with area of sectors, which is on page 35. And so you can see, based on these pictures here, basically what we're trying to do is we're trying to find the area of the shaded region. And so a sector is a section of a circle bounded by a central angle and its intercepted arc. So here's our central angle. There's the arc. The sector is the part that's cut off. And you can think of a sector like a slice of pizza or cake or something like that. So if I just take like a random slice out of this, like an animal, and I'm just taking that piece, that's not a sector. Sector's got to be a nice slice from the middle there. Okay. The formula for the area of the sector is whatever angle is the central angle divided by 360 times the area of the circle, which is pi r squared. Okay. So whatever angle we have, again, it's that divided by 360 times the area of the circle. Let's use the pi button in round, because we'll be doing some delta math in just a sec, so we'll use that. So for number one, what is the degree of the central angle? 51. So we're going to do 51 divided by 360 times pi times 16 squared, because we're told that BC is 16. I'm going to pull up my calculator here to show you how we can enter that. When we're typing that in, we can type 51 divided by 360 times pi, and 16 squared. So we can just type it all in on one line like that, and we get our answer. So notice we don't have to put a multiplication sign between pi and 16 right there. When they're next to each other like that, the calculator knows that you're multiplying. So you don't have to do that. You can if you want. So we get 113.9. Okay. You guys do number 2. Ready, set, go. Okay. So let's check. So we're going to use our formula here. What is x in this case? What is the degree of our central angle? 139. So 139 over 360 times 2, or sorry, not 2 pi r squared. Times pi times, what's the radius?
22.
22 squared. Okay. What do we get when we put that in the calculator? 587.1. Okay, questions on that? All right, let's go to the back page. Okay, so for something like number 11, we're trying to find the total area of the shaded region. So here we have two sectors. So what I can do is, I could do these two separately and then add them together, or I can just treat it like it's one big sector. What would this angle opposite the 46 equal? It would also equal 46, because they're vertical angles. So if they're opposite each other like that, or if they were just next to each other, and it was shaded and this one wasn't shaded, we would get the same answer. They're going to have the same area. So instead of finding them separately and adding them together, I'm just going to add the angles together. So we do 46 plus 46, which equals 92. So I'm just going to do the area like it's one, like it's one big section. So this would be 92 divided by 360 times pi times 7 squared. So I had a 16 there. I had a 16 there, so I was just editing it. Could have pressed delete. So we get 39.34. Technically this would be centimeters squared. Okay. You guys do number 14. Here. All right, so first of all, we need to, there's a couple of things we need to do first. What is the angle of this sector that we're dealing with here? How do we find that?
I did 326 over 360.
Okay, where'd you get 326 from?
I did 17 plus 17, which is 34. And then I did 360 minus 34 for the shade.
Okay.
It's 326.
Do we agree? 326 is our angle that we're going to use? Yes. So we got to subtract those two.
And then it's equal to pi 21.5 squared.
Okay. And so, yeah, RS is the diameter. So the radius is 21.5. So we need to do 43 divided by 2, which is 21.5. So, questions on that one? Okay. We're going to go back a couple pages now. To, or maybe just back one page. To page, it says 33. Yeah, 33. Okay. So arc length is very similar. Take a look at number 1. Number 1, if I was asking you, what is the measure of the degrees of this arc? What would you say? 107. We would say this is 107 degrees. Okay. Okay. Notice our question is telling us to find the length of the arc. So remember, arcs can be measured in degrees or and units of length. This formula here is looking for length. And the difference is, if I were trying to walk along this arc right there, and I wanted to know how far I was walking. This circle here is, it says it's 6 meters. So this is going to be, it's going to be more than 6 meters, but it's going to be like 10 meters or something like that. If this circle is 6 miles, now all of a sudden I'm walking like 10 miles. So the size of the circle is going to, of course, change how long the arc is. But what's not going to change is this arc is 107 degrees no matter what. So make sure we read the directions, make sure we know what we're looking for. If we say 107, but I'm looking for length, that's going to be wrong. If we find the length, but I'm actually just looking for the degrees, then that's going to be wrong. So we want to make sure we're using the right formula. The formula is basically the same. Circumference is 2 pi r. So our arc length is x over 360 times 2 pi r. And notice this is the same formula as area, except instead of the area of the circle right here, I'm using the circumference of the circle. Because area would be shading something in. Circumference is the distance around the outside of the circle. So we want to use circumference when we're talking about length. We want to use area when we're talking about area. X is the degree measure of the arc or the central angle. They're going to be the same thing. Okay, so for number 1, we would say that length is 107 divided by 360 times 2 times pi times 6. So exact same process except for using circumference. So again, the way that we can enter that in the calculator is we can actually type it out just like that. 107 divided by 360. Watch this. Times 2 pi 6. But I don't need multiplication signs right there. The calculator knows that when I put pi next to a number, I'm meaning to multiply them. So you can put numbers on either side, and that will work, just so you know. I do need to put this multiplication symbol, otherwise it's going to think it's 3,602. The more you know. So we get 11 points, 2 more. Okay, you guys do number 4.
No.
Okay. So how do we get this angle right there? What do we have to do? Abby.
Subtract 288 from 360.
All right.
Not expecting it to.
Okay. So then we do 72. 72 72 over 360 times 2 times pi times 9.5. And that's about 11.94. In this case, it would be feet. Not feet squared, just feet. Okay. Let's go to the back. We'll do one more example, and you guys will do one more. So just looking at a slightly more complicated one. So let's look at number 7. So number 7, we're told that BS, the diameter, is 12 meters. So what is our radius? And we are looking for the length of UT. That's what we're looking for. So we need to find the degrees of that arc or that angle right there. We know a few things already. We know that this is 90. We know that this is 127.
So then we do 127 minus 90.
Okay, we do 127 minus 90. Yes, it is 37. Why minus 90?
Because we know the whole thing there is 127, and the part we're looking for is a smaller bit. We subtract the bigger part that we don't.
Are you saying this angle right here would be 127?
Yeah.
Because it's vertical? Yes.
Yeah.
Okay.
So then we know part of it is 90, so we subtract.
Yes. Yeah. The other way that we could do that is we could find this missing angle here is 53. So that would be 53 and subtract this from 90 as well. Either way, yes, that's 30. So this is basically unit 1 of geometry, right? Using vertical angles, using angle addition postulate, linear pairs, et cetera, et cetera. I like that way though of seeing these are vertical angles, that has to be 127 to be subtracted. So again, we just do 37 over 360 times 2 times 5 times 6. Or whatever that is. Okay. Yes, it is delta math.